All right, students, we're going to be talking about simplifying polynomials today. It's actually going to be a review. A lot of the rules and mathematical methods that we looked at earlier in the year, and in turn going to help us look at more in-depth simplifying after bit. So this is going to take care of it for the first lesson here, and then we'll move on to bigger and better things as we go on. Today you're going to be looking at adding, subtracting, and multiplying polynomials, or those operations in polynomial terms. And then we'll move into division, factoring, fractions, etc. after that. The first thing I want to talk to you about is combining like terms. This first polynomial you see here, negative 5x squared minus 3x plus 2x squared minus 6, has some like terms, and those like terms would be the same variable raised to the same power. That's how we define like terms. So I see we have negative 5x squared. That would be not the same as just x, but would be the same as 2x squared, but not the same as negative 6x. Those x's, though, just by themselves, and notice I take the sign with it, those would be like terms in themselves. So when we write this, we're going to say my green terms here, or my x squareds, negative 5x squared plus 2 more x squareds. Negative 5 of them plus 2 of them would make negative 3x squared. So that's combining like terms. That probably sounds really familiar. Then looking at just the x terms, if I have negative 3x's and negative 6x's, we can combine those to negative 9x. And that's simplifying combining like terms. The next step, or the next situation, we're actually going to be multiplying monomials by each other, and we're going to be using what's called the product of powers property. And this product of powers property allows us to justify the fact that maybe an x squared times another x would equal x to the third. And just kind of illustrate that for you, it would look something like this. We'd have x squared maybe times x to the fourth. We would actually add 2 and 4 and get x to the 6th. Or you could think about it as 2 x's being multiplied and then 4 more being multiplied, and that gives you a total of 6 of them. So that's the product of powers property. Let's look at how that affects our problem here. First, start with the easy term. We're going to look at the 5, the 7, and the negative 3. These are called coefficients of the variable. 5 times 7 is 35, times the negative 3 is going to be negative 105. Now let's look at that x squared, x, and the x squared again. So we have x squared, x, and x squared again. This x actually has a understood 1 as its exponent. So if we add all the exponents for our product of powers, because that's what we did down here, 2 plus 4 is 6. If we add 2 plus 1, we get 3, plus another 2 is 5. So that would make x to the 5th power. Let's do the same thing for y's. We have y to the 3rd, y to the 1st, and y to the 2nd. Put the 1st in there as well, just to show you. So now we have y to the 3rd, that's 3 of them, plus another one makes 4, plus 2 more makes 6. So y to the 6th. So when using our answer, or our product of properties to answer this question, to simplify it, we actually get negative 105 x to the 5th, y to the 6th. And that's simplified. How we're going to use this? We're going to use this in some problem-solving terms. We're actually going to put both of these together with something like this. Let's get this out of the way. So now we have negative a squared b times ab squared times a squared b squared. Seems confusing, but it's really not. Plus a to the third times b to the second being multiplied by negative a squared b to the third. And in doing so, we're actually going to combine both of the multiplication as well as, in this case, addition. You might also see subtraction there. So let's take a look and see what happens. Now, each of these would actually be an understood 1 in front of all of it, but 1 times negative 1 is just going to be negative 1. So we'll say negative, or you could put a negative 1 there if you wanted. Let's look at the a's. We have a to the second, a to the first, it's understood, and another a to the second. So 2 plus 1 plus 2 more is a to the fifth. Let's look at the b's. B to the first plus 2 more plus 2 more would be b to the fifth. You can put in parentheses if you want to. Now we hit that addition sign, so that kind of separates our work. That's step 1. Let's look at the next step. If we have a to the third, b squared, being multiplied by negative a to the second, b to the third, let's combine. First of all, they're both understood 1s in front, so kind of like this negative 1, it's going to be another negative 1. And then a to the third plus 2 more is a to the fifth. B to the second plus 3 more is b to the fifth. And again, you put in parentheses if you want to. Now, by doing both of those simplifications or multiplication, I now have like terms. Remember, like terms are the same variable raised to the same power. A to the fifth, b to the fifth, a to the fifth, b to the fifth. They have to match exactly, and in turn, these do. So if I have negative 1, a to the fifth, b to the fifth, plus another negative 1, a to the fifth, b to the fifth, we actually have negative 2, a to the fifth, b to the fifth. And that's going to be our simplified answer. If you have any questions, let me know in email. Okay, you can find the practice PDF on Google Classroom. Thanks for watching.